everyone, and welcome back to Identity Insights by Indicio. I'm your host, Tim Spring, and today I'm joined by Indicio software engineer Colton Wolkins. Today we are here to discuss the difference between DIDComm and today's other secure communication methods and what that means. Thank you for joining us today, Colton. For those unfamiliar, could you start us off with a brief description of what DIDComm is?
DIDComm is a communication protocol that provides both security and removes the need for centralized servers and services.
All right. And how is that different from the other secure communication channels that are available to most people today?
So most communication channels today require some form of centralized server for or like one-off implementations. So, for example, you're building out an application, but then other people can't really use that except your own stuff per se. DIDComm, however, doesn't have any of those requirements for centralization, and it, since it's a protocol, allows you to use it for far more than just like a single use case.
So we've touched on things being centralized or decentralized. I'm curious if you could talk a bit about that, mostly in terms of what we mean when we say centralized and what is the danger of having a system that is centralized.
So the main problem with centralized is that all of your data is essentially in one spot. And no matter what you do on the internet, many people are familiar with like the lock icon in their web browser, whether that is they're in some chat application doing banking operations, interacting with PayPal. The lock icon has signified that the communication is encrypted. And for the most part, those communications are encrypted between you and this centralized server, and the centralized server now knows everything that you're sending to it. And conversely, with many people's users, or with many users using a centralized server, that's a lot of data that could be vulnerable for some malicious actors who, want to harm other people on the internet. And it turns into a very lucrative opportunity for them. Whereas if you switch over to a decentralized architecture, you no longer have all of your messages, whether that's from messaging apps or banking credentials, you no longer are storing those in a single location, a big honeypot fit for an attack. It is now in everyone's pockets, their own little honeypots per se of their own stuff, but it's not like the motherlode of all honeypots.
All right, perfect. Yeah, because you'd have to break into everyone else's phone to be able to try to get their data. You can no longer, because I know Target and everywhere else has been breached, and they're like, oh, we lost 100,000 credit cards or whatever. So let's talk about specifically DIDComm, right? If you could you give me an example of an actual like use case, right? Like say I want to talk to you through DIDComm, and could we point out exactly how it's secure and why? Right, because with the centralized server, I'm sending a message to the server, which is then sending it to you. So there's a middleman there. How does DIDComm work without that middleman? How does that message actually get delivered in that secure way?
So I'm going to use an analogy of like an email mailbox, right? We all have an email account. We know how emails work. Um, let's say I have a Gmail account, you have a yahoo.com account. If I send you an email, it goes from my computer. Um, in the case of email, it goes from my computer to Gmail servers, then to Yahoo servers, and then to you. And if you want to send me a message, it goes to Yahoo servers, then to Gmail servers, then to me. And the way that DIDComm works is it's a similar fashion per se to that, but it's like a hybrid between that and normal web communication. So you go to a website and it goes from your computer directly to the website, or like I go to Gmail and it goes from my computer directly to Gmail. There's no middleman in between. But the web is structured in such a way to protect users' privacy. So, you can't just directly message me if you wanted to, unless I, am a tech wizard and open holes in my firewall and all that sort of techno jazz. What DIDComm allows for is I can, to a server or a service, I can communicate directly to them. And in the case of someone who is behind a firewall, like if I wanted to, message you, send a message to your phone, which normally can't receive messages, then I talk to a mailbox per se that your phone or device or the app manufacturer that you are using has set up. So it goes directly from my phone to this mailbox that they'll hold on to your message. It is end-to-end encrypted, so even though they have the message, they can't open it up and look at it without the keys that are on your phone. And only you can open that up and see what the message is after you have retrieved it from, their mailbox server. And then if you wanted to respond to me, I have a mailbox server that I've set up, similar to like Gmail, where you send a message directly to Gmail, and then they forward that on to me, but they can't see the data, unlike, traditional email today. Gmail can see all of my emails, Yahoo could see all of your emails, et cetera, et cetera. And DIDComm prevents that.
All right, makes sense. So if we were to put it in the context of, today's secure messaging, I'm talking, Signal or WhatsApp or something that, claims to be a secured messaging. Is that pretty much the same? Could Signal read messages or WhatsApp or any of those things? Or what is the difference there?
So the difference there, at least from my understanding, they like Signal and WhatsApp, they have this claim where messages are end-to-end encrypted. I have not, for all I know, for all intents and purposes, that is, messages are end-to-end encrypted. They can't read the messages. But since it's a single app manufacturer, since you can't talk from Signal to WhatsApp and WhatsApp to Signal, it's only Signal to Signal or WhatsApp to WhatsApp. What is preventing these companies from within the app itself turning off that encryption secretly behind the scenes before they publish like an app update? So now all of the messages that you send are in end-to-end encrypted, or not end-to-end. They are encrypted, but they're encrypted to the Signal servers, and then they're in plain text on the servers. Like, what's preventing them from doing that as that like single organization? And they have the ability to just store all of your messages. There's been talks recently about, quantum computing, breaking encryption schemes. Since Signal stores all of your messages on their servers, albeit encrypted, what's the, chance or whatnot that they could just use all this quantum stuff to crack all the encryption that they've already got on all these stored messages from you. With DIDComm, there is no centralized entity storing those messages. It's just my inbox holds my messages for as long as they need to deliver that message to me, and vice versa. There's no centralized server holding on to all of those messages so that like when I log in with a new device, all of my old messages are still there.
Okay, interesting. So yeah, you bring up a good point about even if the data is not centralized, having a centralized provider like just one Signal or one Facebook or whatever controlling everything is potentially a problem as well. What is to stop that with DIDComm? I understand it's an open source project, right? So there's no one main controller making these calls.
Yeah, so it's an open source project, and one of the things that I forgot to bring up is like if the Signal servers go down, if the Signal servers go down, you lose access to the entire service. With DIDComm, it is focused on a protocol first, interoperability first and foremost, along with the encryption. So all of the messages are end-to-end encrypted. You've got all sorts of different providers. Like I mentioned earlier, you can't talk from Signal to WhatsApp and WhatsApp to Signal. But with DIDComm, any DIDComm agent on, like, say, my phone or your phone, they can be made by completely different companies, completely different apps. But because they both speak the DIDComm protocol under the hood, they can still communicate with each other. And so you break out of this cycle of having one organization, running the show. It is, just like HTTP out there, everybody's following the spec. And if, for whatever reason, my app provider turns out to be trying to do something malicious behind the scenes or something, then I can just switch to a different app provider and have all the same exact services. There's no incentive for them to like store all of the data. In fact, all of the incentive is for them to get rid of the data as fast as possible, like not hold on to the data as fast as possible or for as long as possible, and to do good by the users, because by doing good by the users, they do good by the community, and everyone is able to talk to each other, if that makes sense.
All right, I think so. I think it also does help because then, right, without a giant store of data, they also reduce their liability as a business. They spend less on, centralized servers and all that. So there's definitely benefits on both ends, where the users get, their secure messaging and the company doesn't have to deal with the data and the liability nearly as much. So I'm curious for DIDComm, right? If someone were to want to use it themselves, play with it a little bit, learn more, where would you suggest they check that out and where do they go?
So there are a couple of locations. So the specification documents are hosted on didcom.org. But if you wanted to play with it, there are a few apps out there. I know that Indicio has an app. I know the government of British Columbia also has an app. The BC Services Card app. I don't know all of the apps out there because it is kind of an open ecosystem, and we're working to get a more concise list of examples on the website. But yeah, the protocol is all the different protocols and whatnot are hosted on didcom.org. There is a demo that you can play with. It's a developer-oriented demo on demo.didcom.org. It's just something that runs in the web browser. You can have two browser tabs on same computer, different computer, completely entirely different networks, and you can connect them together and send messages back and forth and see how it works under the hood and whatnot. That's all open source. The specs are all open source. But on top of that, we also have a couple of DIDComm user group meetings, one for the America-based time zones and another for the Europe through APAC time zones, where people can join in, they can learn more about DIDComm, get some help understanding things, and also, raise any sort of questions they have or find other people who are using DIDComm.
All right, very cool. It sounds like there's a ton of resources out there for anyone who wants to learn more. It looks like that is about our time for today, Colton. I really appreciate you taking the time to speak to everyone today and share your insights into DIDComm and other secure messaging apps and methodologies. If you at home are interested in decentralized identity and verifiable credential technology and would be interested in learning more, please be sure to subscribe to the channel. We'll continue to bring you some more educational content. If you have any questions or specific topics that you'd like for us to cover, please go ahead and leave a comment below and we'll be sure to read and address them. Thank you all for watching.